The universe is vast and full of wonders. It's a place of infinite possibilities and endless mysteries, stretching far beyond the limits of our imagination. We can see planets, stars, and galaxies stretching out across unimaginable distances. These celestial bodies form a cosmic tapestry that is both beautiful and awe-inspiring, but what we see is only a small fraction of what's actually out there. The visible universe is just the tip of the iceberg, a mere glimpse into the vast expanse of space. Most of the universe is invisible, hidden in a shroud of cosmic mystery. This hidden universe is filled with phenomena that challenge our understanding and push the boundaries of science. This invisible stuff doesn't emit light, nor does it reflect it. It's completely dark, eluding even the most powerful telescopes we have. It's completely dark to our telescopes. Despite our advanced technology, we are still unable to directly observe this mysterious matter. Yet, we know it exists because of its gravitational influence on the things we can see. The way it bends light and affects the motion of galaxies reveals its presence. We call this mysterious substance dark matter and dark energy. These terms represent our current understanding of the unseen forces shaping the cosmos. These two enigmatic entities make up the vast majority of the universe. They are the unseen architects of the cosmic web, holding galaxies together and driving the expansion of the universe. Dark matter accounts for about 85%, a colossal portion that outweighs all visible matter, while dark energy makes up a whopping 68%. This mysterious force is responsible for the accelerated expansion of the universe. That means everything we can see, all the stars, planets, and galaxies, comprises only about 5% of the universe. The rest remains hidden, a dark enigma waiting to be unraveled. The discovery of dark matter and dark energy has revolutionized our understanding of the cosmos. It has opened new avenues of research and sparked countless questions about the nature of reality. It's like realizing that our house sits on a vast, unseen foundation, far larger and more complex than we ever imagined. This foundation supports everything we know and see. But what are these mysterious substances? What are their properties? And how do they interact with the visible universe? And what do they tell us about the universe we live in? These questions drive our quest for knowledge, pushing us to explore the unknown and uncover the secrets of the cosmos. In the 1930s, astronomer Fritz Zwicky observed something peculiar about galaxy clusters. He was studying the Coma cluster, a large cluster of galaxies, and noticed an anomaly that would change our understanding of the universe. Galaxy clusters are massive groupings of galaxies held together by gravity. These clusters can contain thousands of galaxies, all interacting through gravitational forces. Zwicky noticed that the galaxies were moving much faster than they should have been based on the visible mass of the cluster. The speed of these galaxies suggested that there was more mass present than what could be seen. It was as if some invisible force was giving the galaxies an extra gravitational tug. This unseen force was causing the galaxies to move in ways that defied the laws of physics as understood at the time. Zwicky proposed the existence of a dunkle materie, or dark matter, to explain this discrepancy. He theorized that this dark matter was not visible through telescopes, but had mass and exerted gravitational force. This dark matter, he suggested, provided the additional gravity needed to hold the clusters together. Without it, the galaxies would fly apart, unable to stay bound in the cluster. Decades later, astronomer Vera Rubin provided further evidence for dark matter. Her work in the 1970s focused on the rotation curves of spiral galaxies. She observed that stars in spiral galaxies were rotating at the same speed regardless of their distance from the galactic center. This was unexpected because, according to Newtonian physics, stars farther from the center should move more slowly. This went against the laws of physics, which predicted that stars farther out should be moving slower. The uniform rotation speed suggested that there was more mass in the galaxies than what was visible. Again, the most likely explanation was the presence of invisible dark matter distributed throughout the galaxy. This dark matter added the necessary gravitational force to keep the stars moving at a consistent speed. This dark matter halo, as it came to be known, provided the extra gravity needed to keep the stars moving at a uniform speed. The concept of dark matter has since become a cornerstone in our understanding of the cosmos, influencing theories and models of the universe. In the late 1990s, two independent teams of astronomers made a groundbreaking discovery. They were studying distant supernovae, exploding stars that serve as cosmic distance markers. To their surprise, they found that these supernovae were fainter than expected, suggesting they were farther away than previously thought. This discovery sent shockwaves through the scientific community. It meant that the expansion of the universe, long thought to be slowing down due to gravity, was actually accelerating. Something was pushing the universe apart, counteracting the force of gravity. This mysterious force, dubbed dark energy, remains one of the most profound enigmas in modern cosmology. Its properties and origin are still largely unknown, but its effects are undeniable. Dark energy is stretching the very fabric of space-time, driving the accelerated expansion of the universe. Section 4. Hunting for ghosts. Dark matter and dark energy may be invisible, but that hasn't stopped scientists from trying to detect them. These mysterious components make up about 95% of the universe, yet we know so little about them. Astronomers use various methods to study these elusive entities, hoping to unlock their secrets. They analyze vast amounts of data collected from telescopes and space missions, looking for subtle clues. One approach is to look for the gravitational effects of dark matter. This involves observing how dark matter influences the motion of stars and galaxies. By studying the way light bends around massive objects, astronomers can map the distribution of dark matter in the universe. This bending of light, known as gravitational lensing, acts like a cosmic magnifying glass. This technique, known as gravitational lensing, has revealed vast halos of dark matter surrounding galaxies and galaxy clusters. These halos are invisible to the naked eye, but can be inferred through their gravitational influence. Another method is to search for the elusive particles that might make up dark matter. Scientists set up highly sensitive detectors deep underground to avoid interference from cosmic rays. Scientists believe that dark matter is likely composed of weakly interacting massive particles, or WIMPs. These particles are thought to be all around us, passing through us unnoticed. These hypothetical particles would interact with ordinary matter only through gravity and the weak force, making them extremely difficult to detect. Despite the challenges, researchers remain hopeful that they will one day capture these ghostly particles and unravel the mysteries of the universe. Section 5. The expanding picture. The discovery of dark matter and dark energy has profoundly impacted our understanding of the universe. It has forced us to rethink our models of cosmology and grapple with the possibility that we may only be scratching the surface of what's out there. The standard model of cosmology, known as the Lambda CDM model, incorporates dark matter and dark energy to explain the observed properties of the universe. According to this model, dark matter makes up about 85% of the matter in the universe, while dark energy accounts for about 68% of its total energy density. While the Lambda CDM model has been remarkably successful in explaining a wide range of observations, it's still incomplete. The nature of dark matter and dark energy remains one of the biggest mysteries in modern physics.